Hello everyone. Today we're going to show how watsonx.data can enable customers to leverage the data querying tools of their choice while eliminating the need for data duplication and ETL. Traditionally, if a customer wants to leverage a warehouse engine, a big data engine, and a Spark on the same data, they oftentimes have to move data from different storages, thereby duplicating data and creating a need to extract, transform, and load. With watsonx.data, all of that can be eliminated by the integrations that we provided at 3 different points. First, we're making sure that all engines in question can access object storage. Second, making sure all of the supported engine can read off of the same metastore and catalog. And finally, making sure all of these different engines can work with the Iceberg table format. So through these 3 integration points, no matter which engine you choose, it will always look like those data are local to you and in the native format that you can work with. To start things off, we're going to browse data from multiple sources and leverage a single personal engine to combine data together. Here we have catalogs from the DB2 warehouse that's attached with a number of order tables inside. And we also have the Iceberg catalog in the default schema with additional ordered tables. If I wanted to take the order detail table here and combine it against the order header table inside DB2 warehouse, I can do so as they were all in the same environment with a simple select and query statement. And just like that, I was able to perform a left join on the 2 datasets, combining these 2 tables on order number. Now, we want to actually create a new table and have it shared with Netezza. So we're going to navigate to the ThinkDB schema, and we're going to see that there are only 1 table located currently. If we go over to Netezza, we'll see that the same table is also available. If I were to create a table inside of the Think schema on Presto, and there's metadata and data integration between these 2 services, I should be also able to see the table inside of Netezza right away and being able to query from it. So let's create a table. I'm going to take a particular data set from the same DB2 warehouse and go sales schema and land the table inside of the Iceberg ThinkDB's schema and call the table order methods. I'm going to run the create table statement like this, and it should generate the table inside of this space. And if I refresh the ThinkDB catalog, I will see that the order method table has appeared and is available for me to query. And if I so choose to so, I can generate a select statement and take a look at the table. At the same time, over in Netezza, all I have to do is synchronize the metadata store, which also automatically happens every 30 seconds. And just like that, once I refresh the Netezza catalog, look into the same schema, I also see the order method table appear for me to work with. And I can simply select and query, and just like that, a table that I generated inside of watsonx.data with the Presto engine is immediately available to be picked up by a different query engine like Netezza to be worked on by another user. Now that we've seen how a user would perform data combination and discovery today, what happens when we apply generative AIs and large language models that we created to our data management products? Well, here we have Semantic Automation, a tool built on top of the foundational core watsonx.data Lakehouse components to better help data engineers and users discover and transform their dataset. If I'm a user interested in learning about customer churn activities, I can simply ask the chat prompt to provide me tables that are relevant for my question. And once those tables are identified, I simply have to click select and view. You'll notice that the actual table name itself, raw form, is a string. And here are very basic metadata informations. And we can see that more clearly by disabling semantic enrichment. This particular information may not be very useful for people to understand what these columns means and how to take advantage of this data. By leveraging semantic automation, generative AI can provide descriptions, primary keys, tags, and to map any concept and descriptions from a business glossaries that an organization already have, vastly simplifying the discovery process and reduce the reliance on tribal knowledge to understand what data sets means and whether or not they're useful. Furthermore, if I want to combine additional data with this table, all I have to do is tell the chat prompt. Let's say I want to add geographic data to this table. So I will say, let's add residence data to this table. Just like this, the tool can generate the SQLs and necessary APIs to discover the tables that are not only relevant, but also have good containments so that a join against that table can be successful. And if I click on the geographic areas table, you'll notice that it has 100% containments, which means that at least one column has all the necessary rows between the individual churn facts and the geographic data. And I can join this table live and save it to a collection. And just like this, the Semantic Automation tool is generating the necessary SQL to perform the join, as well as enriching the resulting data sets from that join. And just like this, we have a join table, and if you notice, the description has also been updated to reflect the action that I just took, vastly simplifying a data engineer's journey to find, combine, and to maintain the data catalogs on any new assets that's been created. And this will vastly create time to value, as well as provide self-service capabilities to business users to perform these actions themselves.